Okay, so now we are on two streams. We looked at water cycle, we looked at weathering, we looked at erosion, now we're looking at streams. So most streams and rivers do not flow in a straight line. If you've ever looked at a stream or a river, it doesn't go straight down. It usually has some kind of bends or turns, which are actually called meanders. It looks kind of like a snake, and I mean, here's a picture. It looks kind of snake-like, like little meanders all over. And a meandering stream, oh, sorry, with a defined S curve. So like, that's just a little bit. You can see little S's in here, big S's here, a bunch of different S's, right? So in that meandering stream or river, you have an erosional side and a depositional side. So as water follows around the S curve as it's going from here to here, from here to here, all of them, they have a depositional and erosional side, right? On the erosional side, this is where the water is the deepest because it's moving faster and it wears away the bank. It takes it away. The faster it goes, the more it takes. On the depositional side, the water tends to move slower, and this is where the sediments start to fall out because the water is moving slower. Any of the particles that are in it in that a suspension drops out. So looking at this little depiction of a stream, you're going to see that the water comes in, the dotted line is where it's going the fastest. So like right about the middle, and then it hits that meander, that curve. It's going to almost like hit this side, but because it doesn't keep going, it turns. So it starts eroding away right here. And then it's going to come up here, hit this wall, turn, hit, hit, hit. Anywhere it hits, it goes really, really, really fast, and it starts taking away. Whereas the opposite side tends to be slower moving, which means all this fast stuff starts taking stuff as it goes around the curve in that suspension. Anything on this side is going slower, so particles drop out. And according to our reference tables, page 6, the stream velocity, you can see the speed at which all these particles start to drop out. So we're going to use the following stream labeled A through H to answer the questions. So you got A, B, C, D, E, F, H, and G. Which letters represent where erosion occurs? Remember, this is going to be the outside curve where it goes the fastest. So let's look at the arrow. The arrow is pointing up. So if it points up, A is going to be 1. Then let's go down. It points down to C. C is going to be, so A, C, I'm going to go back up, E, A, C, and E. Let's find the depositional side. So the depositional side is going to be the opposite side of the erosional side. That's going to be the side that's going the slowest. So if it's pointing up here, so it's got to be B. Points down here, so it's got to be D. Points up there, so it's got to be F. B, D, and F. Where is the water the deepest? C or D? Where is it going to be the deepest? AKA, where is it going to be the fastest? It's got to be C. Where is the water going the fastest? E or F? Well, where does that stream point? Point, E. E is pointing at E. What is the stream doing between points H and G? Well, it's not going fast and it's not going slow. It's just going straight. We're not going to have one side that's cut out more so than the other side. What do I mean by this? When we do profiles, we're going to do profiles of each of those sections. A to B, D to C, E to F, and H to G. So from A to B, you'll draw a line straight across, if it's not already drawn for you. Then you're going to show where is it the deepest, where is it the fastest. Well, we already said A was the fastest. So we're going to make a little sloop down, and we know B is not, so we got to go up dramatically, kind of like that. All right, let's look at D to C. So D's here, C's here. Well, A got pointed at, C got pointed at, so C is going to be the deepest. So there's my line. I want C to be the deepest. D is going to be less, just like that. E to F, again a line. E is going to be the deepest because it's the fastest. F is going to be the shallower. So it's going to be kind of like that. Sorry, it's a little bit wonky. So let's look at G to H. G to H is just going straight. There's no one side that is more eroded than the other, maybe the middle. So it's just going to look like a normal U or V. All right, well, in some of the pictures you saw, you had a stream going, and then you had like this little lake right next to it. Looks like it could have been a part of it. At one point in time it was. These are called oxbow lakes. It was originally part of a meandering stream, but it got cut off due to the deposition and erosion. So remember, this is where it's going fast, and it is eroding away. So it hits here, hits here, hits here, hits here. So these are eroding away, but these are depositing all the extra sediment. Eventually, all that sediment gets deposited because it's been eaten away on the erosional side. Everything else gets deposited, and it literally cuts the lake off, or part of that stream off, causing what is called an oxbow lake. There is another form that is made due to erosion and deposition. One of them is a delta. They are sandbar-like islands that form when the fast-moving waters right here of the stream hit a slow-moving water like an ocean or a lake. And when that happens, the particles in suspension hit that slow-moving water, and like we said in the erosional unit, the dense particles drop out first. And then as it keeps going, all the other particles drop out. And because of this, it forms islands. All that deposition forms as the sediments drop out. Now, this is a big thing on Onondaga Lake. Every year in the spring, after the snow melt, they have to dig out all of those deltas, because if you leave these deltas there, eventually it's going to cause flooding to occur, because it stops up the stream from coming out. And if the stream can't come out, it's going to push its way over the banks and flood. All right. So I mentioned page 6 of the reference table up in the stream velocity. This is how fast streams have to be to carry certain particle sizes. Sorry, particles. Please write that down. Size particles, certain size particles, like boulders, cobbles, pebbles, sand, silt, and clay. Again, page 6. So what is the slowest, when we look at Regents questions, what is the slowest stream velocity necessary for a stream to carry the smallest boulder? So boulders are right here. And there is where it would be, that line is what you're going to look for, the dark line, where it would be should be boulders all the way up here. So it would roughly be, if I pull it down, it's more than 100, less than 500. So it can't be this one, can't be this one, can't be this one. Hey, it's 300. All right, what is the maximum size particle that can be carried by a 250 centimeter per second stream velocity? So this is 100, this is 200, that's 300. So right in the middle, I'm a little off. It's going to be roughly about 6.4, it looks. It's not 0.0004. That would be like way off over here. 0.001 would be like right in here somewhere. 0.9 or 9 would be right here. Oh, sorry, I'm going the wrong way. 0.004 right about here. 0.01 is right here, which is definitely not close to 250 centimeters. 9 is up here. And we'll notice that it's got to be 6.4. I'm sorry. For the yawn, I'm sorry. According to this, the reference table, a stream flowing at a velocity of 100, ooh, I love it. I can follow it straight up. At a velocity of 100 per second, centimeters per second, can transport. It wants to know everything it can transport from here. That means everything from here down can get transported in that suspension. So it's going to include pebbles, it's going to include sand, it's going to have silt, and it's going to have clay. But let's look. All of it's got sand. Cool. Or sorry, silt. Sand. Yes, it still can have sand, but not sand. It can't be B. Silt and sand. Sand, sand, sand. Good, good, good. So B's out. Pebbles. Yes, yes. Not pebbles. Ooh, D's out. So B and D are out. Cobbles. Oof. It can't do cobbles. Biggest it can do is pebbles. So it's gotta be A. All right, according to the Earth Science Reference Table, which stream velocity could transport cobbles but not boulders? So I would go right up to here, find out this, again, in between 100 and 500. So it's either 4 or 200. It is the 200 because it's right there. All right. So that is it for the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.